And as introduced, our chat's going to focus on software tools for the modern forest engineer. So this slide, we're going to focus on the access side of things, so mainly the roads. We do have functionality for analyzing your cable logging, and we've got some functionality in there as well for survey data collection, so collecting your field notes or hand traverse data, and planning your culvert and bridge sites. So I'm going to touch on everything today for the access, well, not everything, but I'm going to touch on a lot of our functionality for access roads, cable harvesting, and data collection. I'm not going to go into any depth on the bridge sites. If you're interested in that, suggest check out our YouTube page or give us a shout outside of our session today. So one of the caveats that I have on what I'm going to cover is the data sets that I'm using are going to be mostly LiDAR data sets. The reason for that is I get to talk with a lot of folks now from all over the world, and folks in the West Coast as well. And I'm frequently surprised by how many people are doing designs with hand traverse data, and there's publicly available free LiDAR coverage in their area. So I know LiDAR has been a buzzword in the forestry world for a long time, but I think that hype is justified in terms of access planning. It really is a game changer, and there's all kinds of resources for where you can find that data. So just a few notable ones. NOAA has a great database, USGS, and local state governments have their own databases as well. It's not entire coverage, but it's certainly worth looking into when you start your projects out. So back to my past life, planning access for different industries. When LiDAR was first becoming relatively common in the forest industry, I worked for an operation that didn't adopt it immediately. At a field person level, there was a lot of hesitation from people I worked with. There's lots of grumbling, and some of that was just folks don't want to learn a new way to do things. That shouldn't be an issue. It's a pretty simple process, and once you do it once, it's largely duplicating that over your future projects as well. So there really isn't much of a learning curve. And the other apprehension was, of course, if you go into the forest industry, most people like walking around in the woods, and there was this worry that it's going to take away all their field time. That shouldn't be a concern either. It's one of those things that it's going to make you more efficient in the field. It's going to let you focus on other things and focus on more details and just give you an all-around better product. So the benefits of design in general, so this is not just your LiDAR designs, this is your hand traverse designs as well, is can be broken down into two categories. You've got your actual road geometry, and then you've got the ability for this to be much easier to communicate to people that you need to communicate to. So from a geometry standpoint, the big benefits are that it's going to give you all the information you need to make better decisions right in front of you. So you can set your cross section to be an appropriate width. You can have your appropriate surfacing layers on it. You can plan where your ditches are. You can plan your cut slope angles, fill slope angles. And then the really nice thing is that you can move your center line around, and it's going to update in real time to show you that, oh, if I move my alignment over here, my fill slope's spilling out into an area I don't want to affect that creek. Or maybe you have a long fill slope and you should be pushing into a full bench section. Maybe you click around and you realize, oh, I can miss that full bench section. So there's just a lot of the benefits of how interactive it is. And for drainage planning, same thing. You know where things are. Really nice for dealing with placing your pipes. So we don't have a function to size your pipe for hydrology for the diameter, but when you're placing those pipes, if you're putting a culvert in a section of large, if you're putting your culvert in a large fill on a heavy skew, you want to make sure you have the right length of pipe when you go to build that crossing. So you got the geometry there, you can skew it, you can adjust your grade, you can look at the 3D view and place it exactly the way you want and know that that's an appropriate length for the crossing. Cross drains, nice as well, just to see how the ground lays, where you should put those, and make more informed decisions. From a construction cost standpoint, there's the obvious benefits of you can just see things and, oh, if I put the road here, I'm going through a big cut, or we have a big fill, or things are too steep if we choose this route. But a big benefit from a cost standpoint is looking at things in qualitative terms rather than, oh, that's a difficult road. The driver is going to be, for your construction costs, are going to be how much dirt you're excavating and how far you have to move it. So with the design software, you can get updates for earthwork volumes, mass haul movement in real time to make more informed decisions. Now that costing function is also beneficial from a communication standpoint. So if I tell you that I've got a mile of difficult road to build, well, my mile is probably different than your mile, or the mile's not different, but the difficulty that we each envision is probably different. So that's where analyzing your road based on in qualitative terms is beneficial. So you can talk to your builder and say that I'm moving 10,000 cubic yards of dirt in this section of road. He has a better idea how much effort's required to do that. So he can produce a more competitive bid if it's bid work. And from a scheduling standpoint, you have a better idea of how long your builders are going to be in an area. So you can come up with a better plan. Other communication benefits, a little more obvious, the fact that you have a drawing package, you can show your builder exactly how you want the road to look. You set clear goalposts for the project, and from a construction contract standpoint, that can also be beneficial if things go sideways. If you expect a humpy bumpy in block road and they build you a super highway that's way overbuilt for the project, maybe you fall back on the documentation that you've produced from your design to reevaluate how people are getting paid. Another benefit from communication comes down to, I find a lot of folks that aren't designing the roads are relying on senior staff to place the roads in the field. Those senior staff are nearing retirement. They're trying to bring a junior person up to speed. When you're making those decisions in the field, a lot of the time it's not qualitative. I think this is better. Maybe you put a little bit of numbers to it, but it's not a detailed analysis. It's easier to bring someone up to speed. Qualitative terms, you can give them actual guidelines for what you expect, how that road should be designed, and they also get that interactive side of things where they can see as they move things around how that's going to affect their final alignment. So better roads with less planning times and overall theme here. So for those that are designing roads but using a traditional approach with your hand traverse, that leaves much to be desired. So typical workflow for that, you'll have your area of interest, your projected block, or what have you, just an area, I want to build a road in this vicinity. Maybe you take it a step further, you might count contours and figure out grades from where you expect the start of the alignment to be to where you want to get to. Maybe you even bring it over into Google Earth and click in a quick profile. But with that, it's still pretty coarse. You're just looking at a line draped on the surface. You're not evaluating your proposed route in terms of surfaces, so you don't get the extra complexity of seeing how that actually interacts. You can say, oh, I'm going to average this over this for such a difference, but you don't look at the details of I've actually got a big cut in there, a big fill in there, and we can't just push out because that's going to send a big fill slope down to where we don't want it. So you got your area of interest selected, you got a course line on the map, then you go to the woods, and there's a lot of walking around because that question isn't Is there an issue with where I put that road on the map? It's usually, where should I put the road? I don't really expect much from that preliminary alignment. Walk around, figure out your control points, get a lay of the land, and then you start choosing your route, ribbon that in. Once you get it ribboned in, you usually do your level 2 field survey, so your road traverse. Old school way being compass, clino, and the tight chain. If you're still doing a hand traverse and you're kind of on the cutting edge of things, maybe you're using a GPS and a laser instead of a tight chain. With this, your surveyed surface is only going to be as wide as your data you collect. So usually you'll get 50 feet or so either side of center line, and that's all you have. So when you go to actually do the design, that's your footprint that you're stuck designing on. You can move the alignment either way, but you can only go so far. So a modern workflow using LiDAR is a bit different. The big difference is on this front end here. So instead of doing something really coarse at the start, you can do a pretty detailed design without spending much time. So you can make a few general assumptions, and you can look at it with the same level of detail that you would with your final design stage in the previous workflow right at the start. So now this is where we don't take away all the field time. You can do multiple routes, and then when you go to do your actual walk in the woods, a lot of the time your question is where should I put this road? It's, is there any reason I shouldn't put the road here? And then you can look at more details like ground types. You can focus on other things, wood quality, etc. This next step I have is optimization. So we'll talk more about this a little bit later. But our software has got a mathematical optimization side of it that turns the design process into a semi-automated one. So it's going to look at the constraints you applied for your alignment, and it's going to adjust your alignment to minimize construction costs. So we're relying on the survey data for the LiDAR. So this field survey isn't really a field survey. It's usually just going out and marking the route that you've selected. Yeah, so it's, in this case, if you have adjustments from your P line in the previous one, you'll have offsets and whatnot. In this case, usually your P line and L line are the same. And then you can go out and actually finalize things, export your multiplot, which is your design package, and hand that off to the people that are building it. So the rest of my presentation here, I'm just going to go through the recent changes that we've made to the software to make things easier for folks. And I've just got a series of videos that I'll talk through and give a bit more context for how this relates to folks' workflow. So utilization of LiDAR for forest road design. So this is just building that initial surface. In version 8, we went to a 64-bit program so we can handle more LiDAR. And then in version 9, we made a few tweaks for added functionality for thinning and control. I'll just go through here. I'm in the train module. I'm going to add in my LiDAR data, so LAS files in this case. If I'm in different units than what I want to work with, I can do a transformation automatically. And this doesn't have to just be the LAS files. You can work with DEM data as well. So if you're used to working in ARC, it's your raster data types we support as well. Once the data is in, we'll create a surface from those points. And we need the surface to design and plan with. Contours are nice to have just for added context. They're optional, but it's nice to see what the ground's doing. So this is just going to take a moment here. So this will give us a plan view of what's going on, and we'll just take a quick little peek at our 3D view. And as you can see, this is a much larger area than what you get if you did a hand traverse. And there we are. So the next big change was in version 9, we added live maps. So you can add imagery to your terrain files if you'd like. That's been around for a while, but we've added this live maps feature to let you pull imagery from the web. So here we've got that same file. It's LiDAR data. It's obviously georeferenced, so we can just click a feature and we'll click a couple buttons at the top here and it'll zoom to where we're at. Now we can pull imagery from a few different sources. So we've got Google, Bing, MapTiler, and then it's just a matter of clicking save and clicking a couple more buttons, and that image is going to get saved locally onto your computer, and it's going to come in as a background image. So it'll be a separate terrain file just in the background behind those contours that we've previously made. And there we are. So yeah, we can see where everything's at. You could use another image, so it wouldn't be based off of live maps as well, but if you have canopy height images that you want to add in there, you can do a similar thing and just add them in as a separate terrain file and reference that as background. So this one kind of deviates a bit from our focus on roads, but oftentimes the roads are going to be, the location is going to be influenced by where you want to log. So we've got cable analysis software in the functionality in the software. And in version 9, we did a bunch of updates to that. So the big change is the addition of the D-Line Explorer mode. So I'll show that in the video. Other changes are we've added color-coded plan display so we can see where we lose deflection. We've got an auto tail hold functionality, so it's going to set your haulback block at where you lose deflection. And we can generate a loggable polygon based off the D-Line Explorer mode, so that's going to make more sense when I show it. And we've improved some things with our profile display. So here we can set up our equipment. So we can add whatever we'd like for equipment. We can add the variables that are going to influence that analysis. If you're just doing 3-point deflection, it's just the height that matters. You don't need the other details. Then we can add a system for that equipment. So we can choose which equipment we're using, which type of configuration we're running, and then you can set a carriage weight as well. And then we can click this D-Line Explorer button. Zoom in, I guess, first. And we can choose a calculation method that we're using. So this one I'll just use minimum deflection given load. We can set the max length, and the number of radial lines is how many basically spokes on a wheel we're going to shoot out from that location. So we can click around, we can explore, figure out where we get our best deflection. And once we're happy with the location, we can click accept. Those grayed out green lines turn into features. We can click those features, and if we want to take a more detailed look at them, we can look at them in our profile view. We can also look at a data table to get a breakdown of the pertinent tensions and clearance and whatnot. And then, of course, you can do multiple D-Line Explorers in the same file. If you're not happy with where you place it, you can just click elsewhere and it's going to update to the other location until you hit accept. Or if you just want to abort, you can click enable and it goes away. So conventional design with LiDAR. So we've built the surface, we've added in an ortho, and we've figured out where the landing is that we want to get to. So this is that interactive click around, have a much larger area to click around and figure things out than you would with hand traverse data. Yeah, so that's that. The changes recently, so in version 8 we've added it so you can add multiple alignments in the same file. And in version 9 we've made that easier to work with, and we've updated the Project Explorer panel. So here, now this is sped up, obviously. I'm not that quick at clicking around. I'm just going to reference those files that we've already made. So the Topo surface, I'm going to reference the background image that we've downloaded with our Live Maps feature. I'm going to just configure a couple things in our 3D view so it's a little easier to look at and a little more useful. And then it's that interactive approach. So I can click, I can move my initial point over to where I want to start my alignment, and I can click in. So I'm going to start clicking in my horizontal alignment. As we can see in my profile, it's updated in real time. I'm not getting grades right now, I'm just getting a draped line. But as we click through, that's going to update in real time, and then momentarily, I'll start adjusting my vertical profile. So this is iterative. It's you'll move one thing in one view and then you'll want to update it in another. But it's giving you a lot of flexibility to tackle the project. Now, it's easy on easy ground. It's also easy on difficult ground too. If you're laying out switchbacks in the field, they usually take a bit of time, a few cracks at it to get the perfect balance of your cuts and fills. This is a matter of seconds. Here I'll zoom out in the cross-section view. We can see as I pull things around, those different views are going to update in real time. Over here, it's my mass haul diagram, so that's keeping track of my material surpluses and deficits. And I think I've got a few little adjustments before I go on to much more. Oh, one thing that I missed while the video was playing is I've added in curves. So if you're designing a low volume, low speed in block road, you can use a tight curve appropriately, whereas if you're designing mainline infrastructure, you can up your design speed, use appropriate curves for that, and keep things safe for your road users. Just applying vertical curves, and same thing, just a matter of keeping things safe and comfortable to drive on. And then we'll come over here and we'll add a culvert. So I'm just going to do one culvert in this example. It's all kind of the same. I've added that in our location. I'm going to just change the 3D setting so we can actually see the culvert. And we can change diameter. We can also change structure type. I'll adjust it here momentarily. We can change our gradient. You can change your skew, change your length. The length set to automatically daylight from one side of your road to the outside of your fill slope. So, and you can adjust the location, the fill, and whatnot as well. So this, if I'm happy with that, I'll hit recost. I'll talk more about the recost function when we get to optimization, but here we can see that we've got an expected cost to build this of $315,000. Nice thing about having multiple alignments is we can just make a duplicate of that line, so a carbon copy, and then we can adjust it. We can see what option is going to be better. So here, I believe I'm going to speed it up a lot. Yeah, there we go. And we'll design it to the same standards, same maximum, minimum grades, same curves. And we can do an apples to apples comparison, which is the best route. So just wait for that. Yeah. So just the details, the same kind of tweaking I did in the previous alignment. And now that we've got something reasonable, we'll do a recost for this one, and we can see that we're down around 296 for that option, whereas the other one was 315. So pretty useful piece of information to know. All right, so let's jump on to the next slide. So Earthwork Optimization. So in version 9, we added a horizontal optimization. I'm not going to show horizontal optimization in this, but it's built on the vertical optimization, which I will show. So this is taking your design process and turning it into an automated one. The horizontal optimization function that I'm not going to show, it works by adjusting your IP locations that you've clicked in your horizontal and running the vertical optimization on top of that and iteratively going through to find a better solution for your road. So we'll show the vertical and we'll talk about a bit of what's going on here. So the driver for this, I'm going to pause this, is what we have assigned for our ground types. So here we've got different unit costs for our different materials. Now I've just got one material assigned along the length of this road, but here I'm saying that it's going to cost $12 a cubic yard to excavate, $4 a cubic yard to place. So place and compact. These are user-definable values. You can use whatever you want in here. For this, they're probably high values for a forestry setting. Whereas if we have something like solid rock, it's going to be 12, we'll go to 48. This is our movement costs. So we've broken that down into hauling, loading, and we can calculate for the best break between your different categories of material movement. So that's the driving relationship that's going to be used in the optimization. We're going to set up our optimization here. So I'm just telling it that we're going to sample along the length of a road in 50-foot intervals.
Oh, really?
And we're going to set our minimum crests and sag curves. We're going to set our grade constraints. So we'll do a -12, +18. Apply that to our length of road. And this variable up top, the fast curves, that's going to let the curves be butted up against each other. We'll show a little bit more of that later. I've added a control point, so my start of my road's not going to be in a massive fill or cut. And you can add pits and boro sites, add constraints. If you want to control which direction your material is being moved, you can add that in. Things like side cast, full bench construction, it can all be added in. So once that's configured, we'll actually run the optimization. So I'm going to hit cancel here and click the vertical optimization button and hit process. So first it goes through and does that sampling in those 50-foot intervals, and then it's going to spit out a better alignment, better vertical alignment in this case. So we went from $296 for our expected costs to $211,000. Now, nice thing about that optimization, it's nice to narrow down your design and finish things up, get a cheaper design. It's also nice if you have two significantly different options to evaluate them in the same terms. So if you're looking at different options, it's really easy to do a really good job designing one and not so good job designing the other. This lets you standardize the effort that goes into it and gives you an optimal solution for both. So that was the more expensive option with the hand design, and we just made it the cheaper option. So we're down to 211 versus 204, I believe. Now for both of these, I used the fast curves option. So that's curves butted up against each other, no tangents in between them. Probably appropriate for your in-block roads, not great for a main line. So for a main line, I'd go with variable curves and tangents. I'd set a minimum tangent or minimum curve length and a minimum tangent length. Everything else will leave the same. It's going to cost a bit more because it's a bit more constrained. And we'll let that run, and you get a smoother road as a result. All right, there we have it. So we're up at 214, a little bit more, but it's smoother. So let's jump over. Oh, and for those of you that are looking for professional development hour credits, we've got a secret word, and that word is aggregate. So if you don't have video and you're just listening, just the secret word is aggregate. All right. Next we have our multi-plot report builder. So we've added in version 8, adding chapters and an e-library for those chapters and a book to carry those chapters. So before you just had to set up your pages and track them separately. Now we can have pages inside of chapters inside a book, and it makes it really fast to get a complete design package. So here we've got our design that we've been working with. We can click the multi-plot button down at the bottom. And I'm just going to bring in a workbook that I've saved before. So from another project, save the workbook out of it, and I've got a formatted design now. So I've got a plan profile in this. I've got to the right some data tables for volumes and whatnot, a summary of culverts and all that important stuff. If we click through the different pages, it's going to keep the update where the line's located and show you the appropriate line work for each section. Over here in our cross-section view, we can control what sections are displayed. So I've got this turned on to show 50-foot intervals and my culvert location points. If you're worried about keeping a digital copy of this, or working if you're doing something that needs more control for staking, you can export land XML files for construction, staking, coordinate points, and you can export the line work for work in other softwares as well. So field tools, in version 8, we've added the functionality to be able to connect a GPS to RoadEng. And then there's a few updates in version 9 to improve that. So here we'll go through a quick video. So this is the survey module, so where you're collecting your hand traverse notes. With this, we can see the yellow pointer showing us where we're located. Works in the terrain side of things as well, so this is the 3D view in terrain. And then it also works in location. So location's nice, you can see where you're at in the design. This example, we don't have the vertical position turned on, but we can add in a vertical position for where you're at as well if you've got GPS that's accurate enough for that. And yeah, the title says for as-built construction review. It's also nice for just field truthing things. Device types supported. So this is protocols. It's compatible with Garmin and then NEMA and Windows location services. So to connect to that, we just click the GPS tab and then connect, and then choose the source we like. And there we can see where we're at. And again, the vertical position isn't turned on, but we can see where we're at. And the yellow band represents the expected accuracy for that. And very similar in survey, we can see where we're at. And apologies to this example and the next example aren't forestry examples. This is based at our Vancouver office. We can just pulling in the coordinates from the GPS point to georeference the traverse. So yeah, this is our office in Vancouver. And the next example I have is just for a driveway for my house. So that GPS functionality in RoadEng is great, but one of the issues with it is you need a Windows 10 device. So if you don't have a Windows 10 device, we've got a solution for that. That's compatibility with Avenza, which I'm sure many of you are probably using already. Yeah, and you can use that on your smartphone, a tablet, etc. So here, we've got that multi-plot that we've created previously. We can come up to our Save tab and just save it as an Avenza file. So that Avenza file is not actually a georeferenced PDF. What it is a zip file. Inside the zip file, we have a JPEG, a world file, and a JPEG world file, and then the projection data. So when you bring that into Avenza, grab the zip, and it recognizes it as a map. So you can take that out to the field, use Avenza just like you normally would. You can see where you're at. You can collect your points, grab whatever notes you'd like. You can collect photos with it as well, and everything stays georeferenced. I think for this I probably spend too much time actually doing this stuff. I guess it's going reasonably quick. So yeah, you can collect georeferenced images. As you run the app, it's going to show you your position, obviously. It's GPS. And then once you're content with what you've collected, we can fast forward, and you just click the export button in the bottom right down here and export your notes as a KML. So that KML, it's a Google Earth file, obviously compatible with Google Earth. Go and see the points you've collected. You can have your images in those points. You can also work with it in ARC if need be. But the nice thing from a design standpoint is you can bring those same points into terrain. And just like we did before, we have that background for our image. We can add the KML in and just set our symbology for those features. And then we can also add a label for those points based on the information that we've taken. And then we can reference that terrain file into the background and location. So if you're looking to do changes based on a field review of proposed alignment, it makes it really easy to account for the complexities that you encounter in the field. So, yeah, we covered benefits of design, the recent updates we've made to the software to make things easier, and yeah, hopefully everyone got something out of our presentation.